Hello friends, welcome to our YouTube channel. The purpose of this channel is to help students learn from the comfort of their homes. So let's move ahead. So we will be discussing chapter polynomials, which is the second chapter of class 10, and we are today discussing about exercise 2.3. So let's start, friends. So what is division algorithm? For any polynomial, dividend is equal to divisor into quotient plus remainder. This we have been studying since class 7, right? So when written in the form of algebraic expressions or polynomials, if we divide a polynomial px by another polynomial gx and we get qx as a quotient and rx as remainder, then by division algorithm px is equal to gx into qx plus rx. Division algorithm states that dividend is equal to divisor into quotient plus remainder. So px is equal to gx into qx plus rx. So exercise 2.3 question number 1. Divide the polynomial px by the polynomial gx and find the quotient and remainder in each case. We are given 3 parts of this question. I'll be doing one of them for you, and since we have already done this in class 9, I'm pretty sure that you would be able to do the rest of them on your own, right? So let's start doing them. I'll be doing part 2 for you. So here px is equal to x raised to power 4 minus 3x square plus 4x plus 5, and gx is equal to x square plus 1 minus x, right? So before starting doing the division, we would need to put the polynomials in the right order of their powers. Since px is okay, so we will just correct the order of gx. So first of all we'll take the term of square, then single, and then the general term, that is the constant term, right? So let's start dividing. So x स्क्वायर को x रेज़ टू पावर 4 बनाने के लिए हमें x स्क्वायर से मल्टीप्लाई करना पड़ेगा, but because x square would now need to be multiplied with whole of the divisor, so x square into minus x is minus x cube, but since there is no term with power x cube in the dividend, so we will write it here at the end, and x square into 1 is x square, so we'll simply write over here x square. Now changing the signs as we do in the subtraction, x4 minus x4 will be cut, minus 3x square minus x square becomes minus 4x square. This x cube with the changed sign of positive I will be writing at the start because it being the highest power, and then plus 4x plus 5. To make x square equal to x cube, we will multiply it by x. So x cube minus x square plus x. So plus x cube minus x cube minus 3x square plus 3x plus 5. So to make x square equal to minus 3x square, we'll simply multiply it by minus 3. So minus 3x square plus 3x, minus 3 into minus 1 is minus 3. Changing the signs, we get this. So minus 3x square plus 3x square will be cut. 3x minus 3x, and I am left with plus 8 as the remainder. Right? If by chance we are told to verify the division algorithm, then we can now use these divisor, dividend, quotient and remainder to verify the same. Right? Moving on to the next question. Whether the first polynomial is a factor of the second polynomial by dividing the second polynomial by the first polynomial. Again, I will be taking one example for you, and rest you would be doing on your own. Right? So, taking the first example for you, here pt is equal to 2t raised to power 4 plus 3t cube minus 2t square minus 90 minus 12, and gt, that is the divisor, is equal to t square minus 3. Right? So let's start with the division. 2t raised to power 4 plus 3t raised to power 3 minus 2t square minus 90 minus 12. Divided by t square minus 3. So to make t square equal to 2t raised to power 4, I will multiply it by 2t square. 2t square into minus 3 will be minus 3t square. So placing it below the term containing the square term, so 3t cube minus 2 plus 3 is plus t square minus 90 minus 12. So t square into plus 3t, 3t into minus 3 is minus 90, again placing the relevant term under each other, t square minus 12. So to make t square equal to t square, we just have to multiply it by 1, and t 3 into minus plus 1 is minus 3. So minus 12 plus 3 is minus 9. Right? Now since the remainder RT is not equal to 0, therefore the first term is not a factor of the second polynomial. As simple as that. If the remainder were 0, we would have said that the first term is a factor of the second term, because if a term completely divides the another term, then it is a factor of the second term. Right? Moving ahead,
subscribe to our channel and hit the bell icon to continue receiving all notifications as we post new videos.
so question number 3 of exercise 2.3 is that we need to obtain all zeros of the given polynomial if two of its zeros are given to us. Right? So the given two zeros are root 5 by root 3 and minus root 5 by root 3. So root 5 by root 3 and minus root 5 by root 3 are zeros of the polynomial. Let that polynomial be termed Px. Right? Now we know if A is a zero of Px, then x minus A is a factor of px, right? If a is a 0 of px, then x minus a is a factor of px, which means that since root 5 by root 3 and minus root 5 by root 3 are zeros of px, so x minus root 5 by root 3 and x minus root 5 by root 3 are two factors of px. Right, friends? So x minus root 5 by root 3 and x plus root 5 by root 3 are two factors of px. If these are two factors, then their product should be one of the factors of the polynomial. So x minus root 5 by root 3 into x plus root 5 by root 3 is a factor of px. Right, friends? Any problem till here? Okay. So a minus b into a plus b is a square minus b square. So I get x square minus root 5 by root 3 whole square is a factor of px. Right? Which means that x square minus 5 over 3 is a factor of px. Now taking the LCM, we can have 3x square minus 5 over 3 is a factor of px. Right, friends? So I can also say that 3x square minus 5 alone, no need to take over 3, is a factor of px. Now I will be using this one factor obtained, that is 3x square minus 5, to find the other factor of px. Right? So taking it ahead, what we can or we should do is that we need to divide the given polynomial by this one factor obtained by us till here. So how to do that? Let's do it. So 3x square minus 5 will divide 3x raised to power 4 plus 6x cube minus 2x square minus 10x minus 5. So 3x square into x square is 3x raised to power 4. X square into 5 is minus 5x square, placing it beneath the term containing x square. Six x cube minus 2 plus 5 is plus 3x square minus 10x minus 5. So 3x square into 2x is 6x cube. Minus 5 into 2x is minus 10x. Subtracting 3x square minus 5. So 3x square into 1 is 3x square. And plus 1 into minus 5 is minus 5. Right, friends? So we obtained the remainder as 0, and it was very obvious because 3x square minus 5 is a factor of the polynomial. Right, now to find other zeros, we will make use of the division algorithm. that Px is equal to Gx into Qx plus Rx. Gx is 3x square minus 5. Qx is x square plus 2x plus 1. And Rx is 0. Factorizing x square plus 2x plus 1, we get x square plus 1x plus 1x plus 1 equal to taking out x as common from the first two terms and 1 common from the third and fourth term. We get this. So 3x square minus 5 into x plus 1 into x plus 1. Since we already know which two factors will be obtained if we put 3x square minus 5 equal to 0, so to find other zeros, we will simply put the unknown, or we can say the new factors equal to 0. To find the other zeros, put x plus 1 into x plus 1 equal to 0. So either x plus 1 equal to 0 or x plus 1 equal to 0. Either x equal to minus 1 or x is equal to minus 1. Right, friends? So the other zeros as required by the question are minus 1 and minus 1. Now you need to be very careful doing this question, because sometimes this question is asked in the examination stating that we need to write all the zeros of the polynomial. Right? We need to state all the zeros of the polynomial. In that case, your answer would be, therefore all the zeros of this polynomial are root 5 by root 3, minus root 5 by root 3, minus 1 and minus 1. To get full marks, you will have to state all 4 zeros. Right, friends? Moving on to the next question. Question number 4, exercise 2.3. On dividing this by a polynomial gx, the quotient and remainder were x minus 2 and minus 2x plus 4 respectively. Find gx. Right, friends? So हमें मालूम है पॉलिनोमियल, हमें मालूम है उसका रिमाइंडर और हमें मालूम है क्वोशिएंट. हमें डिवाइजर फाइंड आउट करना है. सो वी आर गिवन विद px which is equal to x cube minus 3x square plus x plus 2. The quotient is x minus 2 and the remainder is minus 2x plus 4. Now by division algorithm, we know that the divisor into quotient plus remainder is equal to the dividend. So px is equal to gx into qx plus rx. Right, friends? So x cube minus 3x square plus x plus 2 is equal to gx we need to find into qx, that is x minus 2, plus rx, that is minus 2x plus 4. Right? Now transposing these terms to the opposite side, x cube minus 3x square plus x plus 2 minus 2x plus 4 is equal to gx into x minus 2. So x cube minus 3x square plus x plus 2 plus 2x minus 4 is equal to gx into x minus 2. Right, friends? So x cube minus 3x square plus x and plus 2x becomes plus 3x, plus 2 minus 4 becomes minus 2, and x minus 2 would be over here from the opposite side. So now simply to find gx, we need to divide x cube minus 3x square plus 3x minus 2 by x minus 2. Let's do that as well. So x minus 2 is the divisor, and x cube minus 3x square plus 3x minus 2 is the dividend in this case now. So x into x square is x cube, minus 2 into x square is minus 2x square, minus 3 plus 2 is minus x square, plus 3x minus 2. Now to make x equal to minus x square, we'll simply have to multiply it by x. Minus 2 into minus x is plus 2x. Subtracting it further, 3x minus 2x is x, minus 2 would come down as it is. So plus 1, we'll multiply it with plus 1. So the remainder is 0. Therefore, gx is equal to x square minus x plus 1. Right friends, this would be your answer. Clear? Moving on. This question states that we need to give examples of polynomials which satisfy the given conditions as have been stated in the question. So first part is we need to give an example of a polynomial px and gx such that the degree of polynomial and the degree of quotient are equal. Right friends? Now we know that at the very first step of division, the highest power of the quotient into the highest power of the divisor should be equal to the highest power of the dividend. Right friends? So if the degree of the quotient has to be equal to the degree of the polynomial, it is possible only in one scenario. What is that scenario? The scenario is that the polynomial should be divided by a constant term, because even if the divisor has a degree of 1, then the degree of the quotient would be 1 less than the degree of the polynomial. So if we actually want the degree of the polynomial and degree of the quotient to be equal, there is only one option that we need to follow, and that is that the polynomial has to be divided by a constant term. Right friends? So doing the first part, you can make any supposition. Let us suppose px is equal to 2x square plus 4x plus 6, and let gx is equal to 2. Right, now what would happen? If we divide by 2, so the first term that comes out to be here is x square, because 2 into x square is 2x square. Right? So 4x, 2 into 2x is 4x. Right friends? So plus 6 and 2 into 3 is plus 6. Remainder is 0. Right? So this can be one example that polynomial px is this, gx is this, qx is this, and remainder is this. So this is an example of a polynomial or the whole set of the dividend, divisor, quotient and remainder such that the degree of polynomial is equal to degree of quotient. You just need to be aware of the fact that the degree of the polynomial can only be equal to the degree of the quotient if the polynomial is divided by a constant term. So take an example which takes into consideration this particular point. Right friends? Second is that the degree of quotient should be equal to the degree of remainder. Right. Degree of quotient should be equal to the degree of remainder. So यहाँ पर हम थोड़ा सा उल्टा चलेंगे. हम पहले क्वोशंट और रिमाइंडर को एज्यूम करेंगे. Let qx is equal to, you can take any simple value. I am taking just a linear quotient, and since they need to have the of the same degree, I am taking a linear remainder as well. Right? This is done now. Now what needs to be done? We know that a division does not end until the degree of the remainder is smaller than the degree of the divisor. So one thing is very obvious, that 2x minus 3 can be a remainder only if the quotient has a degree of at least 2, if not more. Right friends? So thinking of a quadratic polynomial as the divisor over here, so let gx is equal to, what can we take? Chalo, let us take x square plus 4x minus 5. Right? You can take even simple than this. You can just take x square minus 5 as well. So now using the division algorithm and finding the value of px. Px is equal to gx into qx plus rx. So gx, that is x square plus 4x plus 5 into qx, that is x plus 2 plus rx, that is 2x minus 3. So multiplying it, we get x cube plus 4x square plus 5x plus 2x square plus 8x plus 10 plus 2x minus 3. Right friends? So x cube plus 4x square plus 2x square is 6x square. 5x plus 8x plus 2x will be 15x, and 10 minus 3 would be plus 7. Right? So this is the required polynomial, and this gives you a set of values for px, gx, qx and rx such that they satisfy the division algorithm and the degree of quotient is equal to degree of the remainder. Right friends? So moving on to the third part. What is that? The degree of the remainder should be 0. The degree of the remainder should be 0. So we can also take the first question that we have done as the example for this, because the remainder needs to be come out to be equal to a constant. Right? The remainder needs to be coming out to be equal to a constant. So how can we do that? Let's understand. But it is always better if we can come up with a remainder which is a constant term, as the degree of the zero polynomial, that is 0, is not defined. So sometimes teacher tend to deduct marks for the same. Right friends? So try to find out a set of values for which the remainder comes out to be a constant. You can again take very simple examples, like let me take px is equal to x square plus 3x plus 5. Gx can be taken as x plus 3, right? Qx and Rx, we'll need to find them, right? So dividing, we get x plus 3, x square plus 3x plus 5. So x into x is x square plus 3x so we are left with 5, right friends? So 5 is a constant polynomial, so its degree is 0, right? So in this way we can find out all the examples for the 3 parts of the question number 5, right friends? I have done one example each for you, but you should try and do more examples for each part on your own. So that was all that it was for exercise 2.3 of chapter 2 in 10th standard. Bye for now. For more informative videos, subscribe to our channel and also hit the bell icon so that you are notified whenever we release a new video. Thank you from Horizons.